Hey, it's Mrs. Marquette, and get excited. We are doing some more factoring today. Today we are going to do some factoring when we can't just do add multiply, even though add multiply is usually the easiest. All the ones that we see today, we're going to have to do some more work. The main thing that we're going to have to remember as far as past knowledge goes is factoring by grouping. So I'm going to do a couple problems to review factoring by grouping. So if I look at A here, I notice that I have four terms, first of all. And when I've got four terms, I typically do factor by grouping. But I also notice that if I look in each of these two groups, I actually have a greatest common factor in the first two and in the second two. So the GCF in the first two is 3, and it's a 3 and an x. So when I factor out a 3x, I am left with an x minus 5. And remember, I always take the sign in the middle, so I've got a minus. And the GCF in 2x and 10 is 2. So negative 2 times x is negative 2x. Negative 2 times negative 5 is negative 10. So then x minus 5 is our GCF again. And I'm left with 3x minus 2. So that's factoring by grouping, and it's really important that you remember this concept. So if you need to go back to a couple days ago and watch the factor by grouping video, please do that. Or look back on your notes. I'll do just two more here. So if I look at my two groups, again, I've got four terms. So the first greatest common factor is 2y, and I'm left with 2y minus 3. And then in the second two, it doesn't look like there is a GCF. And remember, then I'm going to have a 1. And I took the sign in the middle. So 2y minus 3. Now this is nice because then I have a 2y minus 3 and a 2y plus 1. And one last review. I see four terms, so I'm going to factor. I take a 7x for my GCF, and I'm left with x minus 1. I keep the sign in the middle as a negative. Both of those have a GCF of 3, x minus 1, and then I have x minus 1, 7x minus 3. So the reason this is so important is because we want to write all of our problems in the rest of the lesson so they can be factored with factoring by grouping. So this is the kind of problem we'll be looking at when we have ax squared plus bx plus c when a is not equal to 1. So in other words, there's not just an x squared out front. That doesn't happen. There's always going to be a number out in front of it. So when that happens, the first thing we're going to do is multiply a times c. This is going to be called the AC method. So that means that first number and the last number, we're going to multiply them together. Then we're going to list the factor pairs that multiply to AC and add to B. So again, this is like add multiply, just a little more work. Then we're going to rewrite that middle term as a sum of the two factors. And then at that point, we will have four terms. Once we have four terms, we can factor by grouping. So let's see what that looks like in practice. So number 1, it's 3x squared minus 17x plus 10. AC methods means I'm going to multiply a and c, 3 and 10. 3 times 10 is 30. So I would list factors of 30, 3 and 10, 1 and 30, 2 and 15, and I want those factors to add up to negative 17. I see that if I make both of these negative, I can make that work. Okay, so they say negative 15 times negative 2 is 30, negative 15 plus negative 2 is negative 17. So here is the big step. Negative 17x can be written as negative 15x minus 2x. So I'm like breaking that 17x up into those two factors. Okay. Once I have that, then I can just factor by grouping. You'll notice that this is just like A. So we get 3 and an x with an x minus 5, a negative 2 with an x minus 5, and then my x minus 5 is a GCF. We're left with 3x minus 2. Now my problem is written as a product, so we are all done. So we will need to practice a few of these because the first couple times you see it, it's a little weird. But AC method, first multiply A times C, rewrite the middle term, factor by grouping. So 2. Again, first check if it can be add multiply. The reason it can't is because there's a number out front. So I'm going to check A and C. 4 times negative 3 is negative 12. And I want to list the factors of negative 12. So that'd be 1 and 12, 2 and 6, 3 and 4. They have to add up to negative 4. I think if we use these two terms and make the 6 negative, that'll work. So I'm going to write this. 4y squared doesn't change, but negative 4y is going to be 2y minus 6y minus 3. Now you might be asking, is it okay if I switch the order? Sure, absolutely. You will get the same answer in the end. Factor by grouping. So 2y and then 2y plus 1. Negative 3, 2y plus 1. And then 2y plus 1 is our GCF. What's left is 2y minus 3. And that is our final answer. So notice that this is very similar to putting add multiply and factor by grouping together. It's just that one extra step of our AC, multiplying that first times that last number. Number 3, there is a 6 out front, so I can't just do add multiply, I've got to do A times C. So 6 times 2 is 12. I want numbers that multiply to 12 and add up to 13. So I think my 1 and 12 is going to do it right off the bat if I make both of those numbers negative. So I'll rewrite this. 6x squared doesn't change. What does change is the middle term. The middle term is going to be negative 1x minus 12x. And then that 2 also stays the same. Factor by grouping. It looks like my GCF in the first two terms is just an x. And when I take an x out, I get a 6x minus 1. My GCF in the second two terms, I need to keep that sign in the middle, the negative. Then I can take a 2 out, and I still get 6x minus 1. Remember that in factoring by grouping, that should always happen. In this case, if factoring by grouping doesn't work, either we did AC wrong, or it can't be factored. That's possible. So now 6x minus 1 and x minus 2 are my two factors. The 2 out front, it's not just an x squared, so I've got to do AC method. 2 times negative 3 is negative 6. List your factors. It could be 1 and 6 or 2 and 3. The way that I want to get to negative 5, well, really either of these pairs could get us to negative 5, but I need my 3, the multiplication, to be negative. So I know that the signs have to be different. So I think the only way for that to happen is if I have a positive 1 and a negative 6. So let's rewrite 2x squared plus 1x minus 6x minus 3. Remember that we are writing this middle term with your factors that you found. Factor by grouping. I'll take an x out of the first two, and I get a 2x plus 1. Out of the second two, a negative 3. 2x plus 1. That should always happen as long as you've done your work right. And then 2x plus 1 is my GCF times x minus 3. I'm going to let you guys try those last two. Pause the video. I'm only going to put like 10 seconds between here. So pause that video and check your answers when you're done. So number 5 is actually prime. You'll notice that when you multiply AC, 2 times 1 is just 2. And there's no way I can make 2 and 1 add up to 7. So that one's just prime. And then number 6, when we multiply 3 times 2, we get 6. So we do have factors that add up to 5. Once you do your workout, you get x plus 1 times 3x plus 2, you do have to get all the way here. If you had them flip-flopped, 3x plus 2 times x plus 1, that is just fine. Now we're going to go back to our zero product property. So we know that if we have a times b equals 0, so two things multiplied to give us 0, that either the first one is 0 or the second one is 0, or both. So this, as we've seen before, can help us solve some quadratic equations. We always need to make sure that our equation is set equal to 0. Then we'll factor. This time we're going to use the AC method. And then we will solve each equation. Okay, so it's the same process that we've been doing in the last couple of days. We're just going to extend it to the AC method. Remember to always check a GCF first. That's going to be our extra little check here. So number 7 says 11m squared plus 14m minus 16 equals 0. I notice first of all that there's no GCF in the whole polynomial. So this is going to be an AC method. So I've got an 11 and a negative 16. You might need your calculator for this one, but 11 times negative 16 is negative 176. So if I list out some factors, I've got 176 and 1, 88 and 2. This is going to be a little bit of a long list. 44 and 4, 22 and 8, 16 and 11. So go through that list and see if you can find any that could add up to positive 14. I think if I do 22 and 8, as long as I make the 22 positive and the negative 8 negative, then that'll work. So now rewrite. I got 11m squared plus 22m minus 8m minus 16, and don't forget the equals 0. If you start with an equal sign, you got to keep it. So the first GCF, if I'm factoring by grouping, is 11m, and what's left is m plus 2. And in the second two terms, the second group, I keep that middle sign, so negative 8, and then m plus 2 is 0. So I get m plus 2, and 11m minus 8 equals 0. So that's kind of step one. I've factored. Now I notice that my multiplication sign is in the middle, so I can set each one equal to 0. M plus 2 equals 0, and 11m minus 8 equals 0. This first one, subtract 2 on both sides, and I get m equals negative 2. This is a two-step problem for my second problem, so I add 8 to both sides, and 11m equals 8. Divide by 11 on both sides, and m is equal to 8 over 11. So final answer, negative 2 and 8/11. Number 8, again, I check for a GCF. There isn't one in 2, 5, and 3, so I've got to do the AC method, because I've got a 2 up front. So I get 2 times negative 3, negative 6. Look for some terms that multiply to get negative 6 and add to get 5. I know that they have to be opposite signs because of that negative 3. So I think this is going to be the one that works for us. So I rewrite 2x plus x, or 2x squared, plus x minus 6x minus 3. And don't forget your equals 0. The GCF in the first group is x, and I get 2x plus 1. GCF in the second group, I keep the negative, 3, 2x plus 1, and that still equals 0. Continue factoring by grouping, I get 2x plus 1 times x minus 3 equals 0. You'll notice in these problems you're always going to get answers where 1 at least is a fraction, because we'll have this 2 out front. So I get 2x plus 1 equals 0, or x minus 3 equals 0. This is the easier one to solve. X is equal to 3. If I subtract 1 on both sides and divide by 2, then x is negative 1/2, or 3. Okay. If you want to make sure you totally get that, we would just divide by 2 on both sides there. So I'm going to do number 10, and then I'll have you guys do numbers 9 and 11. The reason I'm going to do number 10 is because we notice actually that we have a GCF in this whole polynomial, and that is 3. So I've got 3 times 2p squared plus 5p plus 3 is equal to 0. Okay, hopefully you remember how that works with the GCF. 3 times 2 is 6, 3 times 5 is 15, 3 times 3 is 9. Then we can still do AC method with our remaining polynomial. 2 times 3 is 6. My possible factors are 2 and 3, or 1 and 6. They've got to add up to 5, so I have 2 and 3. So I leave the 3 as it is, and I split this up. 2p squared plus 2p plus 3p plus 3 is equal to 0. Factor by grouping, I get 2p p plus 1 plus 3 p plus 1 equals 0. Notice my 3 is just hanging out on the outside of my big parentheses. That is okay. Just leave him be. He's already factored out. So then we get 3p plus 1 and then 2p plus 3 is equal to 0. So now I've actually got 3 factors, 2 multiplication signs. So either 3 equals 0, p plus 1 is equal to 0, or 2p plus 3 is equal to 0. 3 equals 0 doesn't make sense. Will not happen. P plus 1 will equal 0 if p is equal to negative 1. And 2p plus 3 will equal 0 if p is equal to negative 3 over 2. If you need to do that math, go ahead and solve that equation. Subtract 3 on both sides, divide by 2 on both sides. But your final answer will be p equals negative 1 and negative 3/2. Now you guys go ahead and try numbers 9 and number 11, please. So numbers 9 and 11, number 9 is that same one from before. We can't actually factor it, so we're not going to be able to solve it today. We will in the next chapter learn a new way to solve without factoring, but for now we gotta leave it be. Number 11 we can. We multiply 6 times 2 to get 12, and then do some AC methods. We factor by grouping. Your final answer should have been x equals 2 and x equals 1/6. So if you need to pause to look at my work, that's totally fine, but I'm going to move on. Number 12, this one does not look like an AC method because it's not 3 terms. So I want to figure out what's really going on here. I do see a GCF. My GCF is 3. So I'm going to put a 3 on the outside. And then 3 times 9 is 27, x squared. And then 3 times negative 1 is negative 3. And please note, this 9x squared minus 1, we've seen that form before. That's the difference of 2 squares. So I keep my 3 on the outside, but then I'll need a 3x and a 3x to multiply to get 9x squared, a 1 and a 1 to get 1. And then if I have opposite signs, I'll lose my middle term. So I set that equal to 0, and I have 3 equations. 3 equals 0. 3x plus 1 equals 0, or 3x minus 1 equals 0. This one doesn't make sense. This one, I'll end up getting x equals negative 1/3. This one, I'll get x equals positive 1/3. Please double check that math if you don't see it immediately. And we get x equals plus or minus 1/3. The last one is number 13. Again, it looks almost like a difference of 2 squares, but not quite yet. I do notice that I have a GCF. GCF here is 5. So I put the 5 on the outside, and I get x squared minus 4 equals 0. Hopefully this one is easier to see that it's a difference of squares. So I keep my 5 on the outside. I have 2 parentheses. I need an x and an x to get x squared. 2 and 2 to get 4. Positive and negative to get x squared minus 4. I have an equals 0 because my problem started with an equals 0, so I got to keep it going all the way. Set up equations. 5 equals 0, x plus 2 equals 0, or x minus 2 equals 0. This one does not work. But x could equal negative 2, or it could equal positive 2. So that is some AC method. If you need to go back and watch any of these problems again, that's awesome. If you are ready to try some practice problems, you can go ahead and do that. See you guys later.